About 13.8 billion years ago, the entire universe, including space, time, energy, and matter, was concentrated in a tiny, extremely dense point called a singularity. Suddenly, this point exploded in an event called the Big Bang. This was not an explosion in space as we usually think of it, but rather an expansion of space itself. Immediately after the Big Bang, in just 10 to 32 seconds, the universe expanded by a factor of 1050 in a period called cosmic inflation. At that time, the temperature was extremely high and matter had not yet formed, existing only in the form of plasma, a mixture of elementary particles such as quarks, gluons, and photons moving randomly. About 380,000 years after the Big Bang, as the universe expanded and cooled, charged particles began to combine into the first hydrogen and helium atoms. This was when light began to spread throughout the universe, marking the end of the Dark Ages and the beginning of the observable universe today. Data from the Cosmic Microwave Background, CMB, the leftover light from the Big Bang, is the clearest evidence of this event. Scientists have captured images of the CMB using space telescopes such as COBE, WMAP, and Planck, which have helped determine the age of the universe and how its structure formed. Why the Big Bang is not a science fiction hypothesis. The Big Bang theory is based on proven physical laws such as Einstein's general theory of relativity, combined with modern astronomical observations such as the redshift showing that galaxies are moving away from each other, and the structure of the microwave background radiation that is uniform throughout the universe. Although we do not know what happened before the Big Bang, because time itself begins there, the current scientific evidence is unanimous. The Big Bang is the most reasonable and accurate model to explain the origin of the universe. How did the first stars and galaxies come into being? About 400 million years after the Big Bang, the universe was no longer a place of simple hydrogen and helium. In the cosmic fog of that time, regions of hydrogen gas began to increase in density, gathering under the force of gravity. When they had enough mass, they collapsed in on themselves and the temperature rose high enough to trigger the process of thermonuclear fusion, creating the first stars. This marked the end of the Dark Ages and the beginning of the cosmic dawn. The first stars, called Population 3 stars, were huge, millions of times brighter than the sun, and lived very short lives. But they played a crucial role. They produced the first light and the first heavy elements in the universe. When many stars were gravitationally bound together, they formed giant clusters of stars, and from them, galaxies were formed. A galaxy contains anywhere from a few million to hundreds of billions of stars, along with cosmic dust and dark matter. A prime example is the Milky Way, our galaxy, which contains more than 100 billion stars and is about 100,000 light-years in diameter. Some galaxies form from collisions and mergers between smaller galaxies, creating complex and vibrant structures that have been captured by the Hubble Space Telescope. Stars may seem like pretty dots of light in the sky, but they are actually elemental refiners. In the cores of stars, nuclear fusion continually converts hydrogen into helium. Then heavier elements such as carbon, oxygen, silicon, and iron, depending on the mass of the star. When large stars reach the end of their lives, they explode in supernovae, releasing huge amounts of energy and scattering the made elements into space. It was these elements that later became the building materials for planets, rocks, water, and even living organisms. The birth of Earth and life. About 4.6 billion years ago, the solar system began to form from a giant cloud of dust and gas in the Milky Way galaxy. Under the influence of gravity, this cloud collapsed. The center became so hot that it started a thermonuclear reaction, creating the sun. The remaining matter around the sun began to coagulate into planets, including Earth. Initially, the Earth was just a red-hot rock, without an atmosphere or oceans. During this early stage, asteroids and meteorites continuously collided, causing the Earth to melt from the inside. Heavy elements such as iron and nickel sank to the core, while lighter elements such as silicon and oxygen rose to form the Earth's crust. Ancient volcanic eruptions released huge amounts of gases such as water vapor, carbon dioxide, ammonia, and others, creating the primordial atmosphere. As the Earth cooled, water vapor in the atmosphere condensed into continuous rains that lasted for thousands of years, forming the first oceans. Some hypotheses also suggest that comets and meteorites containing water contributed to the Earth's water supply through collisions during the final stages of planetary formation. How did the first life begin? About 3.8 billion years ago, in the primordial ocean, simple organic molecules, amino acids, nucleotides, began to chemically interact in an energy-rich environment, from volcanic heat, lightning, or hydrothermal fissures on the seafloor. These molecules gradually formed complex molecular chains, such as RNA, capable of self-replication. This was the foundation for the first cells, the simplest form of life to appear on Earth. Over hundreds of millions of years, these cells evolved, competed, and were naturally selected, forming the foundation for all living things today. The formation of the Earth and life is not just a matter of the past, but the roots of humanity itself. We, with our bodies containing ancient seawater and our DNA derived from the first primitive cells, are the result of a chain of events that spanned billions of years. From cosmic dust to intelligent life, the journey began the moment the Earth was born. Geological periods and mass extinctions. After the Cambrian explosion, Earth entered a series of major geological periods: the Paleozoic, Mesozoic, and Cenozoic. Each geological period marked a period of development, differentiation, and even large-scale disappearance of organisms on the planet. During the Paleozoic, marine life such as trilobites, shellfish, and the first bony fish appeared. About 390 million years ago, some fish began to migrate onto land, evolving into amphibians, the distant ancestors of terrestrial vertebrates. Trees followed, creating giant forests of ferns, aspens, and gradually forming the first terrestrial ecosystems. The mass extinctions, the beginning of the end, and vice versa. Earth is not only a place of life, but also a place where life has been wiped out en masse. Over the course of our 4.6 billion year history, our planet has experienced at least 5 mass extinctions, periods in which between 70% and 90% of species disappear in a short period of time. By geological standards, the largest extinction occurred at the end of the Permian period, about 252 million years ago, often referred to as the Great Dying. About 95% of marine life and 70% of land vertebrates were wiped out. The cause may have been supervolcanic eruptions, releasing toxic gases and changing the global climate, or a lack of oxygen in the oceans. Mesozoic, the age of the dinosaurs. After the mass extinction, the Triassic period ushered in a new era, the age of the dinosaurs. For nearly 80 million years, dinosaurs ruled both land and air, with species such as Tyrannosaurus rex, Brachiosaurus, and Pteranodon. At the same time, plants evolved into flowering plants. Insects and small mammals began to appear, albeit in the shadow of the dinosaurs. However, this period also ended tragically. About 66 million years ago, an asteroid about 10 kilometers in diameter collided with the Earth in the Yucatan Peninsula, Mexico, creating a giant impact crater and a global chain of effects. This event led to the death of 75% of living species, including all non-avian dinosaurs, paving the way for the rise of mammals. Mass extinctions, while devastating, are also catalysts for evolution. After each ecological reset, the Earth emerges with completely new species of organisms, better adapted to the environment. The disappearance of one species paves the way for the development of another. It was the end Cretaceous extinction that gave humans the chance to emerge, because if dinosaurs had survived, mammals would likely have remained small, hidden creatures. The emergence and evolution of mankind. About 60 million years ago, after the extinction of the dinosaurs, a small group of tree-dwelling animals, the ancestors of the primates, began to evolve. These animals had forward-facing eyes, flexible hands, and developed brains, three fundamental factors that helped them navigate their jungle environments safely and process complex information. Over tens of millions of years, a small branch of these primitive primates developed into the great apes, which include the direct ancestors of humans. About 6 to 7 million years ago, in Africa, a major evolutionary split occurred. A branch of hominids began walking on two legs, hind legs, a characteristic behavior of our ancestors. This species is known as Sahelanthropus chadensis, or some more recent ancestors such as Australopithecus afarensis, famous for the fossil Lucy. About 2.5 million years ago, the genus Homo, meaning man, began to appear with the species Homo habilis. This was the first species to know how to make rudimentary stone tools for cutting, hammering, and hunting, a huge step forward compared to other animals. Around 1.8 million years ago, the species Homo erectus appeared, knowing how to use fire to cook food, thereby reducing the size of the jaw and increasing the size of the brain, opening up opportunities for intelligence to develop. Homo erectus was also the first human species to leave Africa, spreading to Asia and Europe. Although not our direct ancestors, they were an important link in the geographical expansion of the human species. About 300,000 years ago, in Africa, Homo sapiens, modern humans, began to appear. They had large skulls, high foreheads, developed language communication skills, and the ability to think abstractly. These traits allowed Homo sapiens to organize societies, create sophisticated tools, paint cave paintings, and conceive of concepts of gods, laws, and art, things that had never been seen before in any species. Around 70,000 years ago, humans began to migrate out of Africa in a huge wave. They crossed seas, crossed forests, traveled through the Middle East, Asia, Europe, and eventually reached Australia and the Americas. In the process, Homo sapiens competed with and replaced other human species such as Neanderthals and Denisovans, becoming the only human species that survives today. Humans are not the strongest, fastest, or longest lived, but we are the only species capable of learning, transmitting knowledge, and cooperating flexibly on a large scale. Through our imagination and abstract language, we can create culture, religion, money, law, and science, structures that have no physical existence but have the power to influence the real world. The formation of human civilization and the agricultural turning point. For most of their history, humans lived as nomadic hunter-gatherers, constantly moving in search of food, water, and shelter. However, about 10,000 years ago, in the Fertile Crescent, now the Middle East, a revolutionary change occurred. Humans learned to grow crops and domesticate animals. This was the beginning of the so-called agricultural revolution, the greatest turning point in human history. Instead of having to depend on nature, humans now actively controlled their food sources, from wheat, barley, to goats, sheep, and cows. Permanent settlement in one place caused the population to increase rapidly. Villages were formed, and from there developed into cities, kingdoms, and nations. When agricultural production stabilized, humans began to create a surplus of food, and no one had to farm. From here, specialized roles emerged: craftsmen, priests, merchants, warriors, and officials. This division of labor led to social stratification, with rich and poor, kings and commoners. About 5,000 years ago, the first civilizations such as Mesopotamia, Egypt, India, China, and Mesoamerica began to take shape. They invented writing, calendars, mathematics, laws, and great architectural works such as pyramids, temples, irrigation. States were established to manage the population, collect taxes, organize armies, and enforce laws. As communities grew, competition for resources and territory became inevitable. The first wars appeared, and the victors could expand their influence, forming empires. History has since become a series of collapses and rises, where power, religion, economics, and technology have continually reshaped the world map. At the same time, cultural exchanges, trade, and inventions have spread along routes such as the Silk Road, the Mediterranean Sea, the Nile, and the Ganges. From the wheel, paper, metals, to beliefs in spirits or life ethics, all are products of the evolution of human civilization. Why is agriculture the beginning of all civilizations? Without agriculture, there would be no settlements. Without settlements, there would be no cities. Without cities, there would be no civilization. By cultivating plants and raising animals, humans have moved from being dependent on nature to being the masters of nature, and from there, built the world we live in today. From a tiny point exploding in the universe 13.8 billion years ago, to the emergence of humans and the first civilizations, the journey of life on Earth is a story of great wonder and awe. Each turning point, from the death of the dinosaurs to the planting of the first seed, is a piece in the grand puzzle of cosmic and human history. Though we are a tiny species in the vastness of space, humans are the only creatures capable of asking, where did we come from, and where is the future headed? These are the questions that have taken us from caves to space stations and continue to drive us to endless exploration. What do you think? What have you found that has surprised you the most about this journey of billions of years? Could extraterrestrial life exist somewhere in the universe? Share your thoughts in the comments below. I'd love to know which part of this story impressed you the most. And don't forget to like, subscribe, and turn on the notification bell so you don't miss the next videos of Cosmic Why, where I will continue to answer the strangest and most interesting questions about the world around us.